Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the series of coding Geometry Dash in Java. So in the last tutorial, what we got to was we were able to load in a sprite sheet, and we can now change this sprite just depending on which sub-sprite we get from that overall sprite sheet. So if I just change this, then it changes the sprite being displayed on the screen and everything too. In this tutorial, what we're going to get to is we're going to actually try and add some simple physics and a little player class. So we'll actually be drawing the full player and then just having him fall down and hit the ground, which is just going to be some arbitrary value we choose. That will be the ground. So let's get to this. First, what we want to do is we want to create a new class, and we will just call this player because this is going to be the player class. And I'm going to add this to Git. And then what are we going to need when we're creating this player? Well, if you noticed, I have 3 different pictures for the player, and they basically comprise the different layers. So we'll say we need one sprite for layer 1, one sprite for layer 2, and one sprite for layer 3. And then I'm also going to take in a color for layer 1 color. We'll just say color 1, a color for layer 2 color, so color 2. And this is just going to be so that you can color it 2 different colors as you can in the actual game as well. And we'll just import that real quick. And then we will do this. So then inside of our player, we're going to have 3 sprites. So we'll just say sprite layer 1, layer 2, and layer 3. And then inside of this class, what we're going to do is we're going to have to recolor all the white pixels to whichever color they chose for color 1 and whichever color they chose for color 2. So if you notice the way that the layers are made, we have this layer which is all white for all the pixels that we care about, and then this layer which is also all white for this is the outline layer. And then we have this layer which is all white for the pixels that we care about. So as you can see, I don't even have all the sprites done. So it only works for some of them, but we can test it with those ones, and I will add a sprite sheet that has more of the sprites done as time goes on too. Basically what we're going to do is we're going to go through each pixel in the image that we received, and then we're going to say if it's white, then we want to color it whichever color the player passed in. So pretty simple. You just have to know a little bit about how to manipulate images in Java, which is not too hard. So we'll say threshold equals 200. This is going to be like the threshold, how high of a pixel value. So for white is 255, 255, 255, which is just RGB in the range from 0 to 255. And so 200 will be our threshold. So we'll say for integer y equals 0 until y is less than layer1.get layer1.image.get width. So this is going to be going column wise. We'll say y plus plus, and we'll say for int x equals 0 until x is less than layer1.image.get height. This will be going row wise. We will say color equals a new color, and then we'll say layer1.get RGB XY. And so all this is going to do is it's basically going to tell us what color is at this pixel value inside of this, and we'll say color, inside of this image. And so it's saying it doesn't know what this is because we need to layer1.image.get RGB. There we go. And then what we can say is if color.getRed is greater than threshold, or color.getGreen is greater than threshold, or color.getBlue is greater than threshold. And technically, these should be ands because we want all the colors to be greater than that. I'm just going to change that. So we'll change that to an and. So if all the colors are greater than 200, which means they're all like 255, then we'll say layer1.set RGB, layer1.image.set RGB, and then it takes in an X and a Y, and then an RGB, which is just color1.get RGB. So it's really simple. All this is doing is saying we're looping through each pixel inside of this image for layer 1, going column wise, row wise, and then we say what is the color at this pixel. So we just say layer1.image.get RGB XY, and that gives us the pixel color. And then we just say if the colors red, green, and blue values are all greater than the threshold, which means they're all 255, then we will say layer1.image set RGB, which changes that pixel color to at that XY coordinate to the color that we want. And then we just do the same thing here for layer 2. So I'm literally just going to copy this loop, and then we'll just change this to layer 2, and change this to layer 2, and then we will change this to layer 2, and that should, and then this one to layer 2, and then that should be good. Yep. So then that should change the color depending on those two layers. And then what we're going to do also inside this constructor, before we do all this, we should say this dot layer 1 equals layer 1, this dot layer 2 equals layer 2, and this dot layer 3 equals layer 3. Okay, and then we don't have to worry about the colors because we just changed the color inside here, so we don't actually have to recolor anything. And then what we're going to want to do is, for now, we'll just say a public void. Well, this will be overridden, so we'll say override public void draw graphics 2D G2, and this is going to be extending component, and then this should be good. Oh, and that's because I put that in the wrong place. Don't put that next to your function, put that next to your class. So player extends component, and then this says it's not overriding it, and that's because of this import. So change this to graphics 2D, and we'll say import java.auth.color, and then we can import that from the correct place, which is com.jade. So that's just a name collision. There's a component class inside of auth, so we just have to make sure that we manually import all these classes that knows which ones we're talking about. Okay, and then inside of the draw method, it's really simple. What we're going to do is we're just going to say game object. So we want to draw this picture in the correct place. So we'll say g2.draw image, and then we will say layer 1. So we're going to do layer 1 first, and then we need the x and the y, which is going to be game object dot transform dot position dot x, game object dot transform dot position dot y, and then we're going to do the width and the height, which is going to be we will take a width and a height in here as well for the player width and player height. Actually, we'll probably put that in the constants because the player is always going to be the same width and the same height. So right in here, we'll say public static final int player width equals 42, public static final int player height equals 42. And then we will go back into our player class, which is right here. And I'm actually going to have these inherent in the class too. So we'll say public int width height, and then we'll say this dot width equals constants dot player width, and then this dot height equals constants dot player height. Cool. And then we'll go back down to here. So now we have the width and the height. So we'll just say this dot width and this dot height, and then image observer, which is null. Okay, and then it's going to give us an error because these are not integers, so we'll just cast that to an int, cast this to an int, and all is good. And then layer 1 is not an image, layer 1 dot image, and we should be good. So that's the full line. Kind of a mouthful, but it's all good. Then we'll just copy and paste this. Do the same thing for layer 2. Copy and paste that. Do the same thing for layer 1, or layer 3. All right, and so this should draw the player correctly every time we have it. So let's go back to our level editor scene, test this real quick, make sure it's working properly. So we'll actually call this test object player instead. So I'm just going to change this to player, and then copy and paste that right here, and right here, and right there, and right there. Okay, so we have this copied and pasted everywhere, and now we should be able to say, instead of adding that component, we'll say player comp for player component equals a new player, and control P for the parameters. So we'll say equals, and then we want the sprite sheet dot sprites dot get 0, and then we're also going to want, so we're going to want layer 1, layer 2, and layer 3. So this is layer 1. I'm going to rename this to layer 1, and then copy and paste this. So this will be layer 2. And then this one will be layer 3. And we will change this to layer 2. And this one to layer 3. Okay, and then we'll say this is actually going to be layer 1. Dot sprites dot get 0. And I'm going to expand this just so that we have enough room. and then we'll say layer 2 dot sprites dot get 0, which should be the same sprite for this image, and then layer 3 dot sprites dot get 0, and then we need the colors, so we'll say color dot red and color dot blue. That should be good. Okay, and now we're ready to say player dot add component, and then we will say the player component that we just created. Awesome. And what's it going to say? It's going to say add component and game object cannot be applied to, oh, we're adding the player. Let's add the player component. There we go. Now we should be good. And then let's go and just run this, and we should see it running and drawing a red and a blue sprite for the player. And there we go. We got red. We did not get blue. And the problem was actually really simple. It's just if you go to the player class, this second loop, we forgot to change this last color to color 2. And then if we run this, we should get a red and blue, and we get red and blue. And then if we go back to our level editor scene, and we change these colors to whichever colors we want, so say red and green instead of blue, then it will change the colors on the player. And then you can actually make these more fine-tuned and stuff, which hopefully we'll do. We might add a little player selection thing, which I didn't have in the demo, but we might add that in as a little bit of a last sort of thing that we do. Okay, so that's great. What about when the player is rotated? Because as we know that the player in Geometry Dash is going to be rotating, and that's kind of hard to do because right now the way we draw a square is by saying, if we go here, or the way we draw an image is we just say X, Y, this width, and this height. So how in the world do you do rotations? Well, that is where transforms come in. And this is why I kept saying this is really important, why we say this is a transform and not just a position. So I'm going to actually draw this out a little bit so that we can understand exactly what's happening, and then we'll implement it real quick. One of the ways that they came up with to draw things really fast in video games was this thing called transformations. Basically, what it is doing math on objects in their space. So if we had a square here and we wanted to draw it just like that right there, it's actually kind of difficult because then you have to calculate the slope of this line, the slope of this line, the slope of this line, all that stuff, which can take quite a long time. And so what they did was they came up with a method that was easier. Instead of calculating what it's like, why don't we just have this transformation plane, this XY coordinate where we draw everything starting here, and then we do all of the stuff we need to do on it there, and then finally we translate it to wherever we need it to be in the actual scene, and then we dispose of this whole thing that we just used. This is the basic idea of transformations and having a view projection matrix, all these different things that they have in 3D graphics. And it's what we're going to be using for this too. So basically what happens is, say you want to draw your object here at a rotation like this, what you would end up doing is first you would say translate, and you're actually translating the whole coordinate system to that point. And so basically then it would look like this. And then what you're saying is rotate it. So then you would rotate the coordinate system so that's along the same axis. And then finally you would say scale. So scale the coordinate system to whatever you want that to be. So if you want it to be bigger, then it would be bigger. And then you dispose of this and it draws it back right here using the coordinate frame that was created here. And it ends up with this object that looks like this. The order of operations is important too, because notice if you tried to first rotate this object, so you rotate this whole coordinate plane, then you would actually end up getting something that looks like this because it would end up rotating it down that way. That's not what you want. So you have to be sure that you first do your translation, which brings it down into the center. Then you do your rotation, which draws it at the correct angle, and then you do your scaling, and then it ends up putting it back in the proper place with all these transformations applied to it. And the other reason that this is important is because there's a little bit of math behind it, which uses these things called matrices, which are just big objects like this that contain some values, and these are just the scale, the rotation, the position of your object, and then it gets applied. So they do all this fancy magic with the numbers, and then you end up with this. We're going to do the same thing. It looks really complicated and everything, but it's actually not that hard. You do need to a little bit of linear algebra if you really want to dig deep into this subject and figure out exactly how this works. I'll leave some links in the description that go into this in more depth if you want to learn about how transformations work a little bit more. Okay, so let's code this real quick. So right now we're just drawing it by simply just saying, okay, let's take the graphics object and slap the image on at the X and Y coordinate. Java actually provides some useful methods that we can use. It's something called an affine transform. And this is basically what I was just talking about, those transformations. And so we'll say affine transform equals a new affine transform. And this is just going to give us that fake coordinate axes that we can move around to our heart's content, and then we can draw it according to that coordinate axes, which will be good for our game object. So then what we can do is we can say transform dot set to identity, and this basically is just like reset. So we're resetting the transform, making sure it's completely empty, there's nothing that we have to worry about. And then we'll say transform dot rotate, or actually, like I said, first we translate. This is moving it, so X and Y, and we want to move it to GameObject.transform.position.x, GameObject.transform.position.y. Then we'll say transform.translate, or .rotate, and this takes in a double theta is what it says, and so we'll give it 45 degrees for now. We'll set that to the actual transform, or the rotation of the object that we have, and then you can say transform.scale. And I'm going to leave it at 1.0, 1.0 for now, scaling in the X and Y, and then we'll play around with that afterwards and see what happens. Then we can just basically remove all this and say g2.drawImage, and we want to draw layer 1. We want to draw layer 1 at this transform, and image observer is null, and then we'll say g2.drawImage, layer 2.image transform, and then null. Same thing with the third layer, layer 3 dot image transform and null, and I'll just fix this real quick, say dot image. Okay, and if we run this right now, we should see our player drawn at a 45-degree angle, and that's exactly what we get. So that's pretty great. Now we want this to use the actual player's position and rotation, so we'll go to our transform real quick. Instead of having this as a vector 2, I think it'd be better to just have it as a float, because in 2D, you can only really rotate around one axis, which is the Z axis. You don't really rotate around X or Y at all. And then that's for rotation, sorry. And then vector 2 for scale. And inside of here, we will initialize scale to a new vector 2. 0, 0. And then we'll say rotation equals 0 as well for now. And let's actually go into vector 2 real quick. I think this is just a nice thing to have. And we'll create a empty constructor, which basically just sets X and Y to 0. So we can go back to that transform and then just remove this, because that's what you would want to happen if you have an empty vectors. It's just 0, 0. So we'll do that real quick. And then we will go back to our player class, and instead of doing all this, we'll say GameObject.transform.rotation, and then right here, GameObject.transform.scale.x, and then right here, GameObject.transform.scale.y. And this should rotate, scale, all that stuff to exactly what we want. And then I just realized something too. We should actually, in our transform, initialize the scale to 1, 1, because that actually makes more sense. We don't want to minimize the scale. We want to actually make it what it should be, just like keep it in its original form at first. So draws the player perfectly fine, no rotation or anything. And if we go into our level editor scene real quick, and then we just say right down here, we'll go right down here, player.transform.rotation equals 45, and then we'll say player.transform.scale.x equals 2. So then it should draw a stretched out player, and we get a stretched out player. And then notice how 2, we said in the X direction, what's happening is it's stretching it out horizontally, then it's rotating it. And so we actually get this rotation where it goes this way, and so X is actually going in this direction in that case. So kind of weird, but that is how it should work. And if we were to say player.transform.scale.y equals 2, it will also scale the player up in the Y direction, and we just have a bigger player. And it doesn't look perfect, but that's fine. We'll look into some methods to clear up the little pixelation things that we get and everything too in the future. And then one last fun thing we can do just to see how this works is we can say player.transform.rotation plus equals dt times 0.1f. Actually, we'll do 1. So it's rotating 1 degree per second. And we see the player rotating. And then this actually highlights a problem. It's not rotating about the center. And that's because when we're doing this, we're not translating it so that it is exactly centered on the player. And to fix that, we can just change our rotate method to, if we do a comma in here and press Control P, we see that we actually have this parameters that we can use up there. It's called anchor X and anchor Y. So where do we want to anchor it when we rotate? And we want to anchor it to the center of the player. So we'll say width over 2 and height over 2, which should be the center of the player. And then if we run this one more time, we notice it's rotating about the center now. So that's how we can draw the player, scale, rotate, do all that fancy stuff. In the next tutorial, what we're going to be going over is actually creating a proper renderer that will submit all of our objects so that we can draw all of them and not have to worry about the camera's position, because this will also come into play with a camera. So we might actually do the camera first. So we'll do a camera and a render and make sure that this is all rendering properly. So that will be the next tutorial. Hope you guys like this. If you did, please hit like and subscribe, and I'll see you guys next time.